Back to my favorite subject, drawing lines in 3D. This video will be all about animating morphing splines. The technique I will show you is the driving force behind effects like these. To make these kaleidoscopic looping videos, I used a combination of Mospline, MoGraph effectors and fields, hair generators, and inevitably some Xpresso. I'll demonstrate the principle by first constructing a simple scene and then show you the actual setup to build this loop. In my previous video, I talked about animating attributes in sequence with an offset. I used Xpresso in that particular example, but I also told you that the algorithm can easily be ported to MoGraph, and that's what I'll show you now. Start by adding a Mospline object in the scene. This will be the spline that will morph into different shapes. I will use a text spline object for our example and enter a single letter S in the text field. This will be the shape that our Mospline will be morphing to. As you know, Mospline generates linear splines, but unlike regular splines, its points are recognizable by the MoGraph module and can be manipulated by effectors and falloffs. Think of Mospline as a special case of the matrix generator, with a spline connecting all the matrices. So, with the Mospline generator selected, I will add a Spline Effector to the scene. This will automatically add it to the Mospline effectors list. Go to the Settings tab of the effector and disable rotation. We are manipulating points, so we are only interested in the position values. In the Effectors tab, we have the option to select the spline that will be the guide for our Mospline to follow. Drag the text object into the spline field or use the arrow beside it to select the guide spline from the object manager. The Mospline points jump to their new position along the guide spline. If you now slide the strength value back and forth, you will see the Mospline interpolate between its original shape and the new one. But that's not the morphing effect we're looking for, is it? We want the points to gradually shift into the new position one after the other with a slight delay in a more organic way. So I'll switch to the Falloff tab and make use of the formula field to drive the strength of the effector. Now before we do anything here, let me make something clear. The expression written in the formula input field affects every piece of MoGraph generator it is applied to separately, be it clones, matrices, Mospline points, fracture objects, or Voronoi fracture pieces. Because MoGraph effectors can also act as geometry deformers, the formula in the text field runs on every geometry point or polygon separately. In scripting terminology, the formula runs inside a loop as many times as there are pieces of geometry or MoGraph clones. Also notice that the formula effector comes with some default variables which are unique for each piece of MoGraph generator. These variables represent different properties for each of the pieces, such as position, rotation, scale, UVW coordinates, ID or index, and subfields. On the other hand, count, time, and frequency are values that are shared among all the pieces. In our case, we are working with a Mospline generator, so the pieces at hand represent points. The default formula might give you a feel for what is to come, but we won't be needing any part of that. We've got our own expression to write. As I showed in the previous video, the formula to sequentially animate attributes looks something like this. For every piece, we multiply the animation value by the count and subtract the index number. Then multiply both count and index by the offset value. After that, we add the result of 1 minus offset to the count times offset product. In the end, we clump the result to a value between 0 and 1. Let me copy this pseudocode to the formula input field and modify it accordingly. First, let me get rid of the clamping part of the expression, because MoGraph fields come already clamped by default. Now let's replace some of the variable names with the ones that we have available in our formula field. Count is the same in both cases, but we'll write ID instead of index. Now comes the tricky part. To control the offset value, we'll use the frequency variable, f. The frequency is in fact a custom slider that the creators of MoGraph have made available to us. We can use it anywhere in our expression for all kind of mathematical operations. With all the changes made to the MoGraph module, I would have appreciated the presence of more than just one custom slider, but we have to work with what we have. We need in fact another slider to drive the animation value of the expression, but for that I'll use a workaround. Expand the formula field tree, select the subfield object under it, right-click, and from the New Layer menu, select the solid field. This field has a slider that adds a special attribute to all the points with a value from 0 to 1. We'll use this special attribute value as the animation variable in our expression, and the name for this variable is conveniently enough subfields. Playing around with the slider, we see the points of the Mospline change their position sequentially from the initial state to the new one, guided by the text spline. You can now change the frequency slider until you're satisfied with the amount of offset. That's the basic idea for the effect. Now let's work some more to make it a production-ready tool for our final effect. We have to add more guide splines in the order that we need the spline to morph. With new splines as guides, we also need more pairs of spline effectors and formula fields. Instead of adding a new effector each time, we can duplicate the one we already have with the formula field and expression ready. For better organization, we can make the effectors children of the Mospline object they're going to affect. Each spline effector will have a different spline as a guide, and it needs to be dragged and added to the effectors list of the Mospline object. To avoid confusion, it's a good idea to name each pair of the spline effector and formula field according to the spline object they are linked to. But doing all these steps manually for every spline might be time-consuming and can also have unpredictable results if you mess up the order in the effectors list. So, ideally, we would need a way to speed up the process of duplicating the effectors as children of the Mospline, renaming them the same as the spline they are linked to, and adding them automatically in the field list in the order they appear in the Object Manager. We'll need some Xpresso to do that. First, let me take care of the renaming part. Add an Xpresso tag to the Spline Effector and call it renaming. Inside the Xpresso editor, add an object node which by default points to the Spline Effector because of the relative reference mode it is set to. Click on the upper right corner of the node and get an output from it. The output we're interested in is the spline object that this effector reads as a guide. Now that we have a handle to the object, we need to read the name of that object. So we add another object node and link the output of the first node to the object input of the second. Now this node points directly to the guide spline object. Click on the pink corner to get the name for that object as an output, ready to feed this name to both the spline effector and the formula field. But doing so will rename all of them the same, and that can bring some confusion. So it's a better idea to append the type of object they are after the name. This is called string concatenation. Add two math nodes and set their data type to string. Link the guide spline name to their first input, and in the second input field enter the type of object they are supposed to be. Type _spline effector for the first node and _formula for the second. Now add two additional object nodes. They both point to the spline effector. That's okay for the first one, but the second one should point to its child object. So we type capital D in its path field. D stands for down. This way, we point to the right object, but keep the relative reference mode, so whenever we duplicate the spline effector, the Xpresso tag still works as it should and renames the right objects. You can test the setup by duplicating the spline effector, change the guide spline, and keep an eye on the names of the hierarchy. Now let's automate the process of adding each spline effector to the effectors list of the Mospline object. I've already explained this technique in a previous video, so I'll cut it short this time. You can go and check that video yourself later if you're interested. Append an Xpresso tag to the Mospline object. Rename the tag to Rearrange Effectors List. In the Xpresso editor, add an object node. It will point to the Mospline object by default. Add an object output port. The next node will be a Python node. Delete both input and output ports and add a corresponding link port as an input instead. Connect the output of the first node to that port. Now, let's edit the source code. Create an inExcludeData Python object and store it to a variable called childrenList. This variable represents an empty list of objects that we're going to populate with the children of the Mospline object. Run a loop for all the children of input 1, which is the Mospline object, using the getChildren method, and insert each child to the children list with the InsertObject method. Now we need to write this populated list onto the list of effectors that affect the Mospline. As you see, the list is populated with the spline effectors, which are the children of the Mospline generator. You can see that rearranging the children's order will instantly be reflected in the order of the effectors list. We have now completed a custom asset that will help make the work for our final project way easier. Believe it or not, there are only 2 guide splines in this project and 2 Mospline generators that morph into them at different times. Start by adding a circle spline followed by a helix. Set both radii at 200 centimeters. For better organization, I'll add both guide splines under a null. There's nothing special about the circle, so I won't touch it any further. It's the helix that will get some tweaking. Set the end angle to 2160 degrees, that is 6 times a full circle, and the subdivision to 10. If you watch it from the front view, it looks like a star written in a single line many times over. Flatten the spline by setting the height value to 0. Both splines now give the impression of a star inside a circle. Copy our asset into the scene. Having all our objects under the same hierarchy makes it easy to copy them around. With the Mospline generator selected, go to the Simple tab and set the length to 0. Duplicate the Mospline hierarchy and rename each Mospline 01 and Mospline 02. You're free to get creative and choose other names that make more sense to you. Duplicate the Spline Effector under Mospline 01. Select the first one and drag the circle into its spline field. Notice how the effector is renamed accordingly. Now select the second effector and drag the helix into its spline field. If you play around with the solid subfield value slider, you can get a glimpse of the effect we're after. You can play with the offset value by changing the frequency slider. I'm setting mine to 0.005 and 0.02. It's a matter of preference. Anyway, let's get the second Mospline set up. Duplicate its spline effector and drag the circle in both spline fields. Set the offset to 0.02 for the first effector and 0 for the second. Now we're ready to keyframe the whole thing. You don't have to follow my timing, you can experiment on your own. The whole point is to transition both Mosplines between the spline guides and have a really cool looking procedural animation. It's procedural because it is non-destructive, and you can have totally different effects using as many different guide splines as you want. With the animation of Mospline finished, you might have noticed that there's something missing. The other lines connecting both our splines. Now, I'll reveal to you another important and well-hidden secret in Cinema 4D. We'll have the hair generator create those lines and use Xpresso to position those line ends along our border splines, just like train rails. Select Mospline 02 and add a hair generator. Selecting the other Mospline would have made no difference whatsoever. We just need a geometry to spawn our hair guides onto. First step, disable the dynamics. We won't be simulating anything. What we are seeing in the viewport are not hairs, but rather hair guides. If you do a screen render now, you will see that the hair are much denser in reality, which is something we don't want. So, go to the Hair tab, untwirl the root's parameters, and from the Root drop-down menu, select As Guides. This tells the hair engine to generate as many hairs as there are guides in the viewport. Also, in the Guides tab, change the root mode from Spline Vertex to Spline Uniform, so that the guides root stick to the spline and are equally distant from each other. By default, each hair is divided into 8 segments. To see them, go to the Simulate menu and from the Hair Mode submenu, select Points. Back in the Attributes panel, lower the segment's number to 1. By setting the root mode to Spline Uniform, we've taken care of one end of our guides. Now we want to stick the tip to the other Mospline. That is where Xpresso comes in. Add an Xpresso tag to the hair generator. Before we move any further, let me show you how the hair points are numbered. For every single hair, Cinema 4D starts counting the points from the root to the tip. Then comes the root of the other hair, and then its tip, and so on. The roots are already taken care of, so to calculate the index for the tips, we first need to know how many hair we're dealing with. Add a hair object in the Xpresso editor, set its mode to guide, and drag the hair generator onto the reference field. This node returns the hair count. Subtract 1 from the total count and feed the result to an iteration node. The iteration node is the equivalent of a for loop in programming terminology. So it runs for as many times as there are hair. Iteration starts counting from 0. That's why we subtracted 1 from the count. But we won't be iterating over hair, rather hair points. There are 2 points for each hair, 1 root and 1 tip. To get the indices for all the roots, we have to skip the tip, so instead of counting by 1, we have to count by 2. For example, 0, 2, 4, 6, 8, and so on. So we multiply the iteration number by 2. All fine and good, but we now have the indices for all the roots. We must increment these indices by 1 to get the tips. Add 1 to all the indices using a math node. Drop down a hair point node. Set its mode to guides and use the arrow to set the reference to our hair generator. Feed our calculated result into the index port. We now have to calculate the position for each tip. That we can do using a spline node. So add a spline node. Drag Mospline 01 into the Xpresso editor and link the object port to the spline object input. We want the tip points to be equally spaced along the spline, so we divide the hair index number by the hair count minus 1 and get a normalized value from 0 to 1 for each iteration. Feed the result into the offset port of the spline node and also link its position port to the position input of the hair point node. You may need to set the Xpresso tag priority to generators and increase the value to avoid flickering. Now both ends of our hair stick on a different Mospline. Play the animation and enjoy the hard work. Increase the number of hair to your liking and edit the hair material. I set my color to white. Optionally, you might choose to add a second hair material for the rails and make them thicker. But you can experiment with all kinds of parameters. In the end, it's a procedural setup and you cannot go wrong with anything. The possibilities are endless. Well, this video came out longer than I expected, but I hope you enjoyed watching it and also learned a new thing or two. I intend to keep recording other techniques involving manipulating lines in 3D. I use those quite often in my projects and also feel that someone might take advantage of them or even develop them further. I'll be happy to answer questions if you have any in the comment section. As always, if you like the video, share the knowledge. Until next time, bye.